So different type of LSA type, like the LSA 1, 2, 3, 4. In detail, we are going to cover all these things in depth. What is that DR and BDR election? How it happened? What is the reason behind it? Why we have these things? Because these are the things which is mostly asked in the interview. If you say that I have worked with this OSPF, so obviously they will try to ask something from the DR, BDR, from the LSA type, router ID concept, and something about how the OSPF metric calculation, the route filtering, which is very tricky in the case of OSPF. It's not like our EIGRP and RIP, where you can properly do the route filtering and all that. It's a bit different thing. Route summarization is also a bit different from your RIP and EIGRP. A different type of areas we are going to cover, the virtual link, and all that will be covered in your OSPF. Means from the starting point to the expert level, like till CCI level, we are going to cover. And now I will also try to add something which is in the production network, that how and which kind of problem you are going to face. So that all we are going to cover in our OSPF that you can see here on the screen. Like what is that OSPF version 2 and OSPF version 3? How we can have this OSPF for our IPv4 as well as for IPv6. And all will be through the lab. As we know that we are going to clear our first concept about anything, and then we'll same thing will apply on the lab and practice it. So after the OSPF, well, these are the things which we are going to cover in our BGP. So let's see that. The fundamental concept, what is the BGP, how it works, why we need it, and why we don't need to implement in our network. And then there are different things like our BGP attributes, the neighbor things, a very simple things. The neighbor things can confuse a lot. If you are not good enough in your IGP, means your OSPF, RIP, and EIGRP. So that may confuse you to work with the BGP. So that's why before starting or working with BGP, it's always recommended to have some hands-on practice with your OSPF and EIGR. That makes sense basically. If you just start with your BGP, that's never going to work at all, and you will confuse more. And then it's a totally different concept from the OSPF, RIP, and AIGRP. This BGP is basically for the exterior gateway protocol, means between the ISPs, between ISP and a one big customer. In this condition and which reason we need to use it and why it is very important. We'll see all that, the basic thing. After the basic stuff, the reason behind using BGP between the ISP, you will understand that there are traffic engineering concept, different type of attribute that will use to do that traffic engineering, and all will be based on the lab, not just the slides. So those who are taking the class, they are very much aware that there is no slideshow. These are the professional course. You don't need any slideshow. That already there are tons of document available for the BGP and OSPF. And if I'm going to open that tons of document and to read that, that's not going to make a sense, right? The sense will make when I'm going to take out of that some useful things which is required to you, that required you guys to know from the production point of view as well as from the exam point of view. Because if see the problem is sometimes students think that they need to clear the exam. But see, if you are not thinking from the production point of view, so somehow in a future you will be means you will suffer and you need to revise it, or maybe you need to join the class again. So that's why the slideshow will not be there in all the classes. The things will be there, which is basically about the concept, a real thing, which is already there in the book and your RFCs. We'll see that all things and try to implement that with the help of lab. Based on that topics, I will also assign some tasks that you have to perform after the class. So that will give you a more sense or more clearance about the topics. Like here about the, you can see that the communities, what is that community, how it works, the basic things about your BGP. If I talk about the BGP neighborship, there are different stages, right? So all will be from the scratch. It's nothing like advanced means you will not be, means I'm not going to cover anything from the basic. Obviously, everything will be from the basic to the expert level. That will not help only just to pass the exam, but to also have some hands-on that will help you in a production environment. Like the same thing for the BGP. Nowadays, if you know if you have some working experience, that in each company, or whether it is ISP or the big companies, we have the IPv6. We are working in a dual mode in IPv4 and IPv6. So it's very important to have some hands-on experience for the IPv6 also. So we'll cover that for the BGP as well as for the OSPF also. Then there are some things like these are the different attributes that will be, you see, basically the BGP, it's something which is not like a other routing protocol, which is automated. It's something which is basically totally manual process. Even the neighborship will not be the automated. So it is because you can plan properly which traffic, how the traffic, where the traffic should go, and how much traffic should go for which network and how. So that we are going to see with the help of about these attributes. These are the main thing about the BGP. When you will learn about the traffic engineering, that is the things which is required, like your origin attribute, the AS path, your BGP weight, local preference, all that will be covered here, like the different concept of these BGP, like the IBGP, what is that, EBGP, the route reflector, the configuration. Configuration is something which is required not from the exam point of view. Obviously, it will not be covered in any CCI exam, which it basically is required. Those who are working with ISP, those who are working with service provider, they need to understand clearly what is that configuration. So that will be also covered here in an easy way, in such a way that you should understand, right? Yeah, like here we have the root reflector. What is that? What is that community? Is different type of, and then all the rest thing which is there in the BGP will be covered, like the BGP VPN, how it support the extended community of our BGP support that BGP VPN also. We'll see that all and that. So all this will be covered in your this course that you can see here, right? Based on the different routes and all that. This will be all that will be covered here, right? So let's quickly start with the OSPF. So as I told you, we are going to start with the very basic things from the starting point, and slowly we'll go ahead and see the all different type of LSAs, the big things like the channeling, filtering, summarization, all that will be covered here. It's not a demo class. Don't confuse with that. It's basically a proper class about the OSPF. As I informed you guys in the last class that we are going to start with the OSPF, I'm just going to say to you here what we are going to cover in the OSPF. Okay, right? So this is the proper class about the OSPF. So do not confuse with this the demo class. There is nothing something like this. This class is proper class. The full things we are going to discuss about our this OSPF one by one as we have done for the EIGRP or the stretching part. So do not confuse with this. Okay. So let's see that first. We are going to see about the OSPF and how it is totally different from our the older like the EIGRP and our RIP routing protocol. The first thing will be this, right? This is not the demo class. I just told you guys. This is a normal class which I am starting with the new topic, which is OSPF. Please do not confuse with that. It's not something like that. Okay. So please do not confuse with that. It is a demo class. So please, yeah. So let's see that what we is means how the OSPF is totally different from the previous, like our EIGRP and RIP protocol. So let's see that first thing. Your OSPF is basically a link state routing protocol. What is the meaning of this link state routing protocol? Like in the case of our RIP and EIGRP, what was the case? What was the case? Case was that if I'm going to enable my EIGRP between suppose 8 and 10, 8 is going to exchange its full routing table with 8. 10 is going to exchange all that table with the 8. Same way, 8 is going to exchange its full routing table with the 10. In the case of distance vector, means EIGRP and RIP. Same way, when 8 will get that, it's going to share it with another neighbor like this. Full routing table, they are exchanging. But what was the problem in this distance vector routing protocol? The problem was when my router 5 is getting the route about router 10's network here on that. He is having no information that who is behind router 8. Totally blank. Because 5 is going to get each and everything from the router 8. So there is no information to the router 5. Who is behind 8? Is there any one router, two router? How they are connected? What is the network? Nothing. Whatever they will get the information, they need, the router 5 will only get one information. That if I want to reach on any network of 10, I'm going to reach with the help of my neighbor 8. So you are totally dependent on your neighbor. Like here, 5 is totally depending on the neighbor 8. And he's totally blank who is behind the router 8. There will be no information at all. Nothing. So these are the two problems. Something like suppose you are shifting to a new city and you don't know how to reach to your office. So what you will do in the case of distance vector, you are going to ask your neighbor, hey, how can I reach on this destination? Now it depends on your neighbor's knowledge and understanding about that destination. He is going to tell you, and you are going to blindly believe it. That okay, I will go this way and I will reach the office. Totally blind means you have no information about, no clear picture in your mind how to reach on that path. Whatever your neighbor is going to tell you, you are going to believe it. Maybe it depends on the neighbor. Maybe he's right or maybe he's wrong sometimes. Same thing in your EIGRP and you are totally depending on your neighbor. There is no information at all who is behind my neighbor, how to reach on a particular one network, something which is here supposed. No idea. You are just gonna to send the packet to the 8 and you have no information, totally blind how to reach on that. That is the problem. Because the problem is when you are depending on someone, it means it's sign of a weakness. It's a kind of a weakness because you are not using your own mind, you are not using your own logic. It totally depends on your neighbors. So that is the problem with your distance vector, which is RIP and EIGRP. That it's very difficult to implement RIP and EIGRP in a big topology because of the false routing, because of the some query process and all that. It make it very difficult to configure this RIP and EIGRP in a big topology in a large network. Now, what is then in the OSPF? If you go and check with any production networks, you will see that 95% of the time, 90 to 95% of the time, we are only using OSPF as a IGP routing protocol. Why? Because of the nature. It's a linked state routing protocol. Here, router 10 is not going to exchange full routing table at all to the 8. No full routing table will be exchanged. No routing table will be exchanged at all in the link state routing protocol, whether it is OSPF or your ISIS. Nothing. So how they will know about each other? So what is going to be done here? Each and every router are going to make LSA packet. They are going to generate LSA packet, link state advertisement packet. In this LSA packet, the first thing they will write about who is the creator of this packet. Like it is router 10, so he's going to write its own unique ID, which unique ID will be basically the router ID. That I am the creator of this LSA packet or the originator of this packet. In that packet, they are going to write down there all the information about networks, whatever the networks you have, and the mask information about your metric and all that. You will keep it in this LSA packet. And this is also very confusing. Sometimes students think that will it be a 10 or 20 LSA packet by the R10 if you know about the 10 network? No. Your router 10 is going to keep all that in a one network if they are in the same area or and in the same type of area. So your router 10 will keep all that network in this LSA packet, simply mask and the metric information. That's it. Now this LSA packet will be forwarded from here to your router 8. This. When router 8 will get LSA packet from the 10, what 8 is going to do? 8 is going to store this LSA packet in its database. You'll see that all in the detail in the lab also. Don't worry. In the database, it's going to store. And as it is, whatever there in the LSA packet, whatever he was getting from the 10, without making any change. Let me clear it again. Without making any change in his LSA, if it is in the same area, or it is going to send it to the router file without making any changes. Even the checksum of the packet, right? The checksum of the packet will not be changed. Nothing will be changed. And it will be saved with your router file. When router 5 is going to get it, he will know that, okay, this is someone else. This is someone else, not my neighbor A, because of the router ID. And also there will be one more information that how this router 10 is connected to the router 8. So this time R5 is getting the information that there is a someone behind my neighbor A. And how that router is connected to my neighbor 8, that information also will be there in the LSC. So what is the difference here now? Now R5 is getting a proper visibility that there is a one person or one router behind my neighbor 8 and how he is connected to my neighbor 8 on which network. What is the network type? What is the network ID on that? All that my R5 will get. Something like, suppose you are shifting to a new city and you don't know how to reach to your office. So what you are going to do this time? In the case of link state, you are going to open your Google Map. In the Google Map, you are going to type your destination, and the Google Map is going to show you something like a 3 to 4 ways to reach on your particular destination. Now you have a proper visibility. Which will be the best? Which will be the best route for you to reach your destination? Zigzag, maybe the toll-free path or the toll path, the very less time-taking path. It depends now on your own requirement and your knowledge and understanding that which path will be best for me to reach my destination. The same thing is there in the link state because each and every router are getting the proper information, the full visibility. So they are going to take their own decision. They're not going to depend on the A. Whatever you are going to send me, I will use that metric and add my local metrics to that and reach on that network. No. Each and every router are getting their LSA from each other. So they will check it and they will take their own decision. This time what happened when R5 want to reach on this network of 10? It's going to calculate its SPF path from 5 to this network here directly if they are in a same network. Whatever I'm talking right now, it's just about the one area type, not about the manual. Okay. So this is the case in your link state because each router are totally independent. They are taking their own decision that which path will be best for me, how to reach on that. That's a reason it support a very big topology. Those OSPF support a very big topology or the large network because of this reason. First reason. Second reason. But after the invention of OSPF, within a few years, it was very clear to everyone that OSPF behavior is also the same like our distance vector in a large network. Why? Because suppose your network is big. There are something like 50 to hundreds of routers are there. And if you are keeping that all the router in a one area, what was the reason? What was the problem? Each and every router is generating their LSA. So flooding of LSA you will see all over the network. Every time this router or that router is flooding their LSA. A lot of packets you will see on the local network or that environment in the whole large network because they all are in a one area. And every time a single network is going down, suppose any network is going down and there are 200 routers. So all the rest of 199 routers are busy to calculate the path, how to reach on that network. Is there any other way to reach on that or not? So that was simply a big chaos. It was big, difficult. Same the problem with our distance. So once it was realized that OSPF will be also not a good decision for a large network, so the OSPF came up with the new solution, multi-area concept. In the multi-area concept, what they say that if you are configuring OSPF for a big topology, divide that big network into the many small networks in a subpart by the using area concept. So that is the reason nowadays we are using the multi-area concept for a large network. multi-area OSPF for our large network. Because the problem was, if you are going to configure a single area OSPF for a big network also, or the large network also, that's not going to work means it's not a scalable solution to configure OSPF for a big network, a large network. That's something which is very difficult to manage. So that's why the OSPF having the concept of multi-area. In production environment, if you go and see, you will always see the cues that we have the multi-area OSPF concept. Right? So this is the basic difference, link state routing protocol and the distance vector routing protocol. Distance vector means RIP and EIGR. Link state means OSPF and ISS. In the link state routing protocol, each router are exchanging the LSA packet. They're not exchanging the routing table at all. No way. They're exchanging the LSA packet. With that LSA packet, they are getting the extra information that what is the reason, who is behind my neighbor, and how to reach on that neighbor. What is the way how it is connected to my neighbor? All that. And they're taking their own decision totally independently. They're not depending on the neighbor. How to reach on that, how to reach on this network? No way. So that make is a very efficient solution for a large network, for internal network, where you can configure your SPF in a big or the large environment also by using the multi-area concept. All right, this is the first thing. If it is clear or you have any question, you can raise your hand or you can unmute or you can write in the chat box. It is all allowed. You can ask anything. The basic difference between the link state and the distance vector. In the case of distance vector, routing table was exchanged. But here in the OSPF and ISS, no routing table is exchanged at all. And there is a proper and full visibility is there.
Hello, sir. I have a
Yes.
question.
Yes.
You told there will not be any change in the LSA packet while it's passing through a router, right?
Yeah, in a one area. Yep.
Yeah, but you again told there will be an information of path, network path in the LSA. So how it will add the information of
Let me
network
tell
path?
you. No, don't confuse with that. Not the path. It will be here one information. Router 10 will write that how I'm connected to router 8. Like this way. Router 10 is connected to the router 8 on which network. That information will be there. Not the path that how I'm connected to this, I'm going via this to this. No, this information will be there. The connectivity information, with whom I'm connected. So R10 will write that I'm connected with the R8 on this network.
So, only R8 to R10 only. It will not
That
add R.
information because see, right now in this topology, I have no information. Suppose if there is a one more round here between 8 and 10 and there is a one more. So that information will be also there. All that routers you are connected to, you will write that information in that.
Okay.
All you are going to mention. Yeah.
Sir, I think LSA through LSA1, every router will advertises everything to whole router, right? For domain.
Did I say anything about the LSA?
No, I say that from LSA1 that router can understand everything
Yes,
about the
yes.
link
Yeah.
and
Yeah,
how
I
many
will come.
routers.
Yeah. So see, this is the only thing. Not I'm talking about the type of LSA or anything else. I'm just telling that what information will be there in the LSA. You are somehow right. We'll come to that point once I will go for the LSA type. Okay. So this is the all information will be there. Okay. So because if I just yeah. Yes.
So
Go
take
ahead.
one small topology and extension. Don't take this much of routers and connecting to switch. Take 1, 2 or 3 router. You can extend.
Definitely. Don't worry. I am
Because
going to
now
when I will take the lab example, I will just take these 2 routers or the 3 routers. That's it. And I will show
so
you the each and everything what I'm talking here.
Okay. For example, as my understand, router 1 LSA is generated. The information is sent to router 8, correct?
Correct.
Okay. In router 8, it is not sending all information to router 5, correct?
Router 8 will generate its own LSA also and will send it to the 5 as well as to the 10. Each router will generate their own LSA. Yep. That is important. Each router is going to generate their LSA and they will write their router ID. Who am I? So that is the only way, because see, if the 10 is going to send that one, let's say, then how they will know about each other's, right? Because here the OSPF intention is not to provide the information of 10 to the 5 only. 5 also need to generate its own LSA, and it need to send it to the 8, and then 8 will forward it as it is to the 10. Same way, 8 will generate its LSA, will share it with the 5 as well as with the 10. Each and every router will generate their own LSA. Yeah.
Sir, got it, but you can take on 3 or 2 router or 4 routers. It
Definitely,
is very
definitely. Don't worry. I will just
because
take a
in
two round. See, this is the main topology will be done only after clearing all these small things, right? So do not worry about that. When I will go and configure it, I will just take a two round. And a lot more thing I need to clear. Basically, the problem is in the books or in the online classes. The problem is nobody is going to take these things in a detail or in a clear way. Now, if I suppose there is many books, if you go and check in the online classes also, if you ask with anyone, what is that summary LSA? Hardly 10% you will get a right answer in the book as well as in the online class. So I'm going to take all these very easy go. So once I will clear that, you will never need to check the book or any online videos. So because you may be the new, so you are not knowing about how I'm going to teach that. But once I will take that, you will understand that yeah, how easily I'm going and taking each and every step by step. It doesn't mean that I'm going to configure it. See, don't confuse with the topology. That I'm going to take all that 10 router in a one go and configure the OSPF for the multi-area. Nothing will be like that. A easy way, what I just clear about the LSA, how they are generating, how they are becoming the neighbor, and how they are extending the route. So what I will do, I will just take a 3 routers only these 3 routers.
okay. As I understand,
And will show.
every router is generate own LSA. So who it
Correct.
is directly connected, the information is exchanged, correct?
Correct. See, obviously, when R10 is generating the LSA, it can only share with the 8. And R8 is going to forward that to the next neighbor. Because see, LSA packet cannot jump, right? Because these are the interfaces that you have. So this is also confusing thing. What the student think that the LSA 10 is going to send it to the all. So obviously, how the packet will go? It needs to flow somehow this way, right? So it will go on that link to the 8. 8 is going to forward that to the 5. So the same LSA from the 10 will reach to the 5 also. And same LSA from the 5 will reach to the 10 also. But yeah, with the help of neighbor. Because 5 has no way to jump and directly send it to the 10. Is there any way? No.
Okay.
Okay.
One more question, sir. See,
Yep.
now
Yep.
the LSA reached R5. Okay.
Mm-hmm.
Now R5 want to forward this traffic to R4. Suppose. So this
Mm-hmm.
R5 will add the mm, R5 ID in the path, or how?
Let me
I
tell you.
was
What I
I'm not
told
clear.
you that each router is generating their own LSA. When 10 is sending that LSA to the 8, it is not adding into that anything in the 10 LSA.
Mm,
Nothing will be added by the 8. Even 8 is not allowed to change the checksum bit. Means
mm,
not a single bit is going to be changed by the 8 router. That is
okay.
100% true.
Mm,
8 when send it to the 5. 5 is also
mm,
a storage. It will not make any changes if it is in the
okay.
same area and send it
Okay.
to
Then
the
it's
router
fine.
4.
Then it's fine. So the
Now,
destination
what
router
will
will
be the
calculate.
case? Yeah. Yeah.
Mm,
Now, what will be the case for the 5? 5 has its own LSA also, right? So he's going to
mm,
share that LSA to the 4. Same way, 8
mm,
has its own LSA. It will share it with the 5.
mm.
So each or every, nobody is allowed to change any other's LSA in the same area. Nobody. That's not the case. Okay. This is very important to understand.
Yeah, it's clear. It's clear.
Okay. That's good. If it's clear, let's move ahead. Small things we'll see. First of all, I will clear one more doubt. I know that maybe something like a 50 to 60% because from the last 15 years, when I ask this question, 50% reply, I get the same. So let me write that, how to configure it, which is very basic command. My motto is not to give you the command or to force you to remember the command. My clear concept about you guys that if you are going to learn something, do not focus on the command. Let your fingers to remember the command, not your mind. Your mind should only learn the concept. Okay, if you think that by knowing the command, how to configure the virtual link, how to configure the SAM link, how to configure this and that, is going to make you a something very means intelligent or the expert. That's totally wrong. Yes, you can ask.
Sir, actually, I have one question. If each
Yes,
router
yes.
have its own LSA, then how router 4 know about the information about router 10?
Each router have their own LSA. Then,
How router 4 have information about router 10?
yeah, let me tell. See, I just cleared that. I think you missed it. No problem.
Actually,
Yeah.
I
Oh,
think I
no
missed it,
problem.
sir.
No problem. So each router, when they are generating their LSA, they are going to write the who is the originator. Which is router ID in that LSA. Any router, when they are generating the LSA, they will write their ID, unique ID, that is called as a router ID. So that is the way how they will know that R4 will know that this is coming from the router 10, which is the means they will not know about this name R10. They will know about the router ID. Hey, I'm getting this LSA from the router ID. This is a one router with that only. Okay. And R4 will also get that. How this 8 and 10 connected, then how 8 and 5 connected, how the 5 and 4, that all information. So that way the R4 is going to calculate the path, how to reach on that network of the 10. Each router, when they were generating their LSA, they will write their unique ID, that who is the owner of this LSA. That will be always there. Clear?
Okay.
All right.
So sender
Now
and
let's,
receiver,
yeah.
both IDs are mentioned in that packet.
Sender and receiver. Why the receiver? Sender, who is the originator? I am writing anywhere the sender? No. The originator. Who is the originator?
Okay.
Yeah. Why means how you get that sender and receiver things?
Mm,
Yeah, you can ask me if you have any doubt, you just clear it. See, R10 is generating that, it's sending it's to neighbor.
okay.
That's it. 8 is forwarding that same to the 5. 5 is forwarding to the same to the 4. 10 is not aware about that. Means OSPF has nothing, no knowledge. Even if when I will configure it on the R10, R10 will never know who is my neighbor. What is the IP address of R8? Is there any routing protocol in a whole world where the 10 is going to know about who is my neighbor and what is the IP of my neighbor? No. So how it works, I will show you that also. That how the packet from 10 will reach to the 8, that I will also clear. Because this is also which is not covered in any course or in any video course or anything. Hardly it will be covered in a something like a 10 to 20%. So that doubt I will clear to today also, that how the packet from 10, because it is ultimately a IP packet, right? And if it is an IP packet, there will be two things, source IP and destination IP. So
Mhm.
what will be the source? What will be the destination? That I will also clear it.
Okay.
Those who have done the EIGRP don't know, they know about it very well. But I will clear it again in the OSPF. Yeah, so the first command, obviously, I will type something like this, router OSPF 10. It is a one way only. There are many other ways to configure the OSPF. Second command, I will type something like this, network, and whatever the network you have on your router's interface. The router's interface, I'm saying. You will type that network, something like suppose it is this 108.0.0.0.255, and then area ID you need to mention at that. This way you will type the command. What is the meaning of first command? Obviously, this command is not to enable, means activate your OSPF routing protocol in your router. The first thing your router, once you will try to enable the OSPF, a router is always going to search about router ID. If router is not able to get the router ID, you will get the error message. Hey, OSPF cannot be enabled on this router 10 because it fails to get a router ID. So suppose you have a new brand router, because it is the case when you join with them, or if you have the working experience, that you most of the time you get a new router and you think that let's configure the OSPF first, then we do the rest thing. So if you are going to configure OSPF without doing anything on the router, on a new brand router, you will get this error. Why? Because there is no interface configured. All the interface in a down condition. So router means OSPF will not be able to pick a router ID. And if router is not able to pick a router ID, It always going to give you this error. OSPF is not be able to enable on this router because of this error. And you will confuse them. That's why the simple router OSPF 10 command is not working. You may search it here and there on the Google, on the community platform, because a lot of community questions comes on the Cisco and as well as any other third-party platform also. So these are the questions which is up. So it is very important. The moment you will type the command router OSPF 10, the router is going to automatically going to start with searching for the router ID. And if it is not able to find out, it will give you the error that it cannot be started. Or other case, if suppose automatically you don't want to enable, so then you have to manually type the router ID. There is a one provision also to type that router ID manually in a IPv4 format. It's not something like a router ID. You can type any number like this, 34, like a 10, 310. No, it has to be in a IPv4 format. An interesting thing, even when you enable your OSPF for the IPv6, in that case also your router ID will be in a IPv4 format. Means something like this, in a dotted format, like this. You have to type your router. Automatically it can select if there is any IP configured. That is a different thing. We'll see it how it works. But yeah, this is the way how it does. The first thing. After that, we have a network command. Quickly in the chat box, if you guys are interested, you can write that. What is the meaning of this network command? Those who have done the EIGRP class, they don't need to reply. Those who are the new with this OSPF, they can reply that or can unmute. What do you think about this network command? For what purpose we are using?
Network command is to advertise the IP to the network. Okay, the particular IP which has been assigned to that particular interface, and it should be advertised via some protocols. In this case, we
Okay.
are advertising via OSPF. Hello, am I audible?
Yeah. I got that. I got it.
Yeah, this is the
So this
main
is the
purpose.
usual, yeah. This is the usual reply from any student. Let me tell you now on word. Always remember, this is totally wrong. Totally wrong. 110%. Go and check it again, but in some reference book, not here and there. This is totally wrong. This is not the reason of this command. This is the byproduct of this command, not the real reason of it. See, this network command is used to advertise the network in BGP only. In the case of OSPF or RIP or EIGRP, this is not the real reason. This is not the real reason. So for what purpose it is? So this command is basically forcing my router, my OSPF, hey, go and search. If you find any interface which having these three parts as it is exact, enable the OSPF on that interface. That is the meaning of this network command. Once it is enabled, your router then will add in the LSA packet, that network. So advertisement is the byproduct. A real reason is your router then is going to search, hey, is there any interface on my router which having the first three major part 155.1.108.0? If it is there, enable the OSPF. So remember from now onward, this network command in the case of routing protocol, except BGP, it is for enabling OSPF on that interface. Not the advertisement is the byproduct, because see, suppose I have a two interface on my 10. One is this 155.1.108.0 network, something like this, and this one is my 155.1.37.0/. So what it mean? If I go under my router OSPF 10 and I write the command this network 155.1.0.0, just a second. If I go under the OSPF and I write the command this, network 155.1.0, 0.255, 255, and area something like a 0 this way. So what is the meaning of this? Is it my router 10 is going to advertise this network 155.1.0.0? No. This time my router 10 will go, OSPF will go and search, hey, is there any interface on my router 10? Is it starting with two major parts, 155.1 or not? Yeah, it will get this time this one, it will get this time this one. So with this command, what is happening now? These two networks will be added in my LSA table. According to your logic, it has to be advertised to my neighbor, but no, it's not happening. You will see that in reality when I will show you in the lab that my this network is not being advertised. My these two networks are being advertised. Why? Because this command is to enable your OSPF if it is matching with your interface network. Once it is enabled, then your router will add that network in the LSA. That is the real reason of this network command. And that's something which is 50 to 60% student, even the working professional, if you go and ask, they will reply the same as I get it here from you guys. So from now onward, always remember, whether it is EIGRP, RIP routing protocol, or OSPF. In all that three cases, this network command is to search. Your router will search, do I have an interface which is starting with this major point 155.1 or this 155.1.10? If it is there, enable that OSPF on the particular interface. Once it is enabled there, obviously your router, your OSPF will include that network in the LSA. So this is not for advertising. It is only in the case of BGP. When suppose I'm going to type this command in my BGP, yep, your reply is totally 100% correct, that it is basically to advertise my network. But there is also some condition, there is some catch that you will learn, that it doesn't mean that under your BGP, if you go and type any network, it's going to send it to my neighbor. No, there is a catch. We'll see that in the BGP. All right. So is it clear the two commands about the router OSPF and the network? What is the meaning of network command? Now, what happened? The moment you will enable your network command, obviously, it will be enabled on this interface also, here on router 10. What's router 10 is going to do? The moment it is enabled by the network command on any interface, the first step your router 10 is going to start. Hello, packet. Every 10 seconds by default on the broadcaster. Every 10 seconds. Doesn't matter whether I'm going to enable it on the 8 or not. Once it is enabled on this interface E0/0 on the router 10 is going to start sending that hello packet every 10 seconds. But there is one more problem. Let me clear that also. That if you are sending the packet, hello packet or any kind of a packet, IP packet it is basically, and in IP packet, two things is required. What is that? Source IP and destination IP, correct? Source IP and destination IP is required. So source IP, there is no problem. Always remember, when router is originating any packet, like a ping packet, traceroute packet, routing protocol packet, or anything, when any device is generating that packet, the source IP will be outgoing interface IP. So in this case, router 10 has no problem with the source IP because this IP will be the source IP here because it is sending on this interface. So outgoing interface IP will be always the source IP. Any packet which your router is generating. So yeah, my OSPF hello packet, my router 10 is generating. So that will be the IP. Now, what will be the destination? Because in this command, I'm not mentioning anywhere router OSPF 10 and then my network command. I'm not mentioning anywhere in this command that where is my neighbor 8? What is the IP of my neighbor 8? Nowhere. So what router 10 will do? Will it get the information automatically? No way. There is no command in a world by which router 10 can get the IP address that is what is configured on the router 8 side. No way. So what your router 10 is going to write in the destination IP? In the destination portion, your router 10 is going to write a multicast. What is that? A multicast IP. Why? Because there is no way, no provision in any routing protocol to know the IP address of your neighbor. So you will use the multicast. Now, every router, if it is enabled with the OSPF, they are listening for this multicast type. If it is enabled by the OSPF, each routing protocol have their own. Like your RIP is running on 224.0.0.9, your EIGRP on 10, your OSPF on this 5, the hello packet that you are sending, right? So that is the trick, because any router is not going to know what is the IP of my neighbor. You can manually configure it. There is a provision, but by default, if you are not configuring, router 10 will use the multicast. And now when this packet will reach on the hello packet reach on the 8, and if 8 is not enabled with the OSPF, 8 will drop the packet, discard the packet that, hey, I don't want to receive it. He will check the multicast IP and he will compare that this multicast IP is basically for the OSPF, and OSPF is not enabled on my router 8. So he will discard the packet. So that's going to be happen the first thing, the moment you will type your router OSPF as well as the network command. Clear? Any doubt? You can ask about these two commands and the first step which is going to be happen. After that, there are many steps. We are going to cover all that step by step. This is the first step. Now, suppose when it is configured on the 8 also, like the same way, router OSPF 10 and some network on the router. What happened now? That is second step. Second step will be now exchanging hello packet with each other. Both the router 10 and router 8. What they will do by exchanging that hello packet with each other? Once they will exchange the hello packet with each other, they are gonna to, okay, what is there in the hello packet? What information you are going to write? Each router is going to write the information about router ID, hello and dead interval, neighbor address if there is any neighbor, area ID, router priority, DR and BDR IP, authentication or the password, and the area type. These all information will be there in the hello packet. And out of that, what router 8 and 10 is going to match? Hello and dead interval should be the same. Area ID should be the same. Authentication, if there is any password is configured, the password should match. And if you are using a different area type, so the area type should also match. If these 4 parameters basically matching, they will become the neighbor with each other. Router will become if all these parameters. What is that? Hello and dead interval, network type, area ID, authentication, area type. If all these are matching, they will become right. Once they become the neighbor, what will be their state? Means once they have exchanged the hello packet, initially their neighborship will be in a down state. Once they will exchange the hello packet, their state will go into the two-way. Two-way means anytime when you are able to see that your neighborship state between the two routers is a two-way, it means they have exchanged hello packet with each other, and they have seen to each other's IP in the neighbor table of the router from 8 to 10 and 10 to 8. That is the two-way condition. After that, the third step will be your sorry. Before the down, there will be a one more, which is called as the initial step. In it, which is basically to starting your sending the hello packet. In it. This is the third.
So after hello packet, it is init state or two-way state?
No. First init is you are going to start sending, means about to send your hello packet.
Okay.
Just see the moment 10 is going to send the hello packet and 8 is received it. So the moment you will receive it, your state will be as the init. Once you will see in hello packet your own IP in the hello packet from the neighbor, your state will be the two-way only. Means when 10 is sending it to the 8, it will see that, yeah, in that neighbor table, he's writing my IP. And the 8 will send it to the 10, then we'll see, yeah, in the neighbor table, it is writing my own IP. So that will be the two-way state of the neighbors.
Okay.
Now, after that, once they will be able to see that, they will go in the next step, which will be the X standard. In that state, what will be the X standard? In that state, one election is going to be happen that is called as DR and BDR. That I'm not going to tell you anymore right now. In network type, will cover it. So right now, just understand there is a one concept of DR and BDR. So that DR and BDR election will happen. Right.
Yeah.
After that, they will go into the exchange state. That's it, which is very confusing sometimes. What is the reason? Let me show you the exchange state. Why it is confusing? Exchange.
So one question: this multicast IP will be always this 5 only,
Obviously.
or direct IP address will be used to send hello packet?
Yeah. See, if you are configuring the neighbor ID, means neighbor command manually, then obviously the destination IP will be the unicast in that case. If you're not using, then only it will be this. It will be the
Okay.
same in your EIGRP as well as in your OSPF. So sometimes what problem we get? One side we have configured that as a unicast sending the packet, and one side it is a multicast. So that may create a problem with the neighbors. So if you are if you are configuring your neighbors manually, always your unicast packet will be exchanged. There is no point then to use the multicast. All right. In the exchange state, one packet is exchanged by the 8 and as by the T. That is called as a DBD packet, database description packet. That is called as a database description packet. This packet. What is that packet? Most of the time, not the student only, even those who are the working professional. What they think that in the exchange state, basically they are exchanging the LSA packet. That's totally wrong. In this exchange state, they are only exchanging the DBD packet. What is that DBD? It is basically the summary of all LSA that you have on router 10. Router 10 is not going to share instantly all the LSA to the 8. No. It will say that, hey, I have a 5 LSA, and this is the summary of that. Which one you want from my side? Same way, it will send to the 10. Hey, I have 10 different LSAs. I'm sending you the summary only, the name of that. Tell me which LSA you want out of that 10. So they will now negotiate. Okay, I have this in my database. I don't need this one. I have this one also in my database. I don't need that. So in this exchange state, they are only exchanging your summary of the LSAs. What LSAs they have. Now it depends on the neighbor. Neighbor is going to demand now. Hey, I need only out of 10, 5 LSA because 5 already I have. Same way the 8 is going to inform. I need only 3 out of the 10 because I have already 7 in my database. So that's called as exchange step. After that, the next step will be your loading. In that loading, basically the real LSAs are exchanged. Real LSA will be exchanged between the routers. That is interesting. LSA and LSU. Do not confuse. I will clear that also. What is the difference between the LSU and LSA? Okay, do not confuse that. Right now, just focus on the LSA, right? Now, the real LSA will be exchanged between the routers in the loading stage. Once it is done, your neighbor state will go into the last, which is called as a full. Full means you have done all the exchange of LSA is done between the two router 8 and 10, and your neighborship will be established. And you will get a log message also for that the neighborship is going up between 8 and 10 router. So these are the different stages, and these are the meaning of each and every one. So in a two-way step, suppose your neighborship is there stuck and it is not moving on. So something which is called as an MTU problem, you will be able to see that in the production net. And after that, in X start state, if it is not able, means basically two-way or the X start, it will be the case of MTU, something like that, or the network mismatch, or the network ID, or the mask is mismatched. Only then you will get this problem. Otherwise, straightforward, it will go from down to the full by having these stages: initial, two-way, X start, exchange, loading, and full. Once loading is done, all the LSAs are exchanged. What router is going to do? The third step. Third step, you store that all the LSA in OSPF database. All the router. 8 will store it in OSPF database, and the same way the 10 is going to store it in own OSPF database. Then what is going to be done? Now, router will run SPF algorithm, shortest path first algorithm, to find out routers are going to take this. They are going to run the SPF algorithm. That how short, I mean, in a bit shortest path I can reach to my this network. A particular one network they will pick at a one time, and they will find out how to reach. So basically, what they are doing, they are calculating the max rate, how to reach on that particular network, and each router is doing it. They are totally independent. They are not using the concept of taking it from the neighbor and adding their own local metric to find out the way. No, they are going from 8 till suppose there are 3 routers till there, if it is in the same area. And then the last step will be the best route will go to routing table. This is the 5-step process, how OSPF works. Once you enable your this command, these two commands, router OSPF and the network ID. Always make sure that if you are getting a chance to revise it, that network command is not something to advertise in your RIP IGRP or OSPF. It is something to enable that. The advertisement is the byproduct of it once it is enabled. Because the example I gave you here, if I read the network 155.1.0.0, it doesn't mean that my router will advertise this network. No, it's going to find out, is there any interface on my router which having the first two major part as a 155.1, and that network will be, that interface will be enabled by those. So be clear about these things. These are the 5-step process of OSPF. If any doubt till now you have in this OSPF, how the neighborship is established between the two routers, ask me.
This process ID means what? This router OSPF. Then there is a number, right?
Yeah, there is a number that is called as the process ID. This process ID, I think. Okay. So this process ID is basically, it's a totally locally significant to any route. Locally significant means I can use any other process ID on R8, but still they will become the name. There is no such problem like a EIGRP. That if this process ID is same, then only they will become the neighbor. No problem. The process ID concept or the AS concept in the case of EIGRP, the reason of it, suppose in a same router, you want to run more than one OSPF instance and you want to keep them separate. Do not mix anything. Like suppose something like this. Suppose 8 and 10 are working in one OSPF process, maybe the 10. And then 10 and one another router here. There is a one more chat. I will check that. Let me clear it first. There is a one more router here. Yes. 10 and this router want to not mix up their route. So what they can do, they can configure another OSPF process here, maybe the 20. So whatever is there between 10 and this new router will never be mixed up with these two routers, 8 and 10. So if on
So
a
you
one
mean to say
router,
that
you
between
want
the
to
process
run,
ID,
yes,
between the process ID, we need to do the redistribution to exchange the route, right?
110%. That is the only reason why we have the process ID or the S number. That they should be keep separating the routes. They should never mix up the one OSPF process to another OSPF process. No way. So that is the reason. I mean, suppose it depends. See, these are the things which depends on the production network requirement. There are something one network here, one network here, and they now are going to merge into the one. So at the starting, I don't want to use a one OSPF process. I want to use a separate things. And according to the requirement, I will redistribute it in my network. So that is the reason. The OSPF process has only significance if you want to run more than one OSPF in your single route. And in that case, the router will never mix up the OSPF 10 to the OSPF 20 or with any number. All right. Ralph is going to want to ask something. Yes.
Sir, by the process ID, it will form another group, right? It will forward the LSAs and in that particular group only, right?
Let me tell you, the process ID, as I told you, it will never mix up. Suppose between 10 and this new router, suppose this router is a 11 number. Router 10 and 11 is using a process ID 20 to run that. So this LSA from the 10 and 11 will never go here between 8 and 10. No way.
That means we can run in a single router more than
One OSPF process. Yeah.
process,
We can
right?
run 2, 3, 4, 5,
I
65,000 there are some.
yeah. I have another question. Many time I am
Yes.
facing this question. You know, every time in interview asked him that when the OSPF
Your voice is not clear. Hello? What happened? Any problem?
no
Can
no
you guys
yeah,
hear me?
hello
Yeah. Yes, I can hear you
yeah
now. Yeah.
yeah actually many time I'm facing the question from interviewer that you know OSPF is stack in extra state. That means M2 problem that is happened. But what is the role of the M2 on neighboring process? Because suppose why M2 is reason for the stack in extra state?
Yeah, see, the reason is this.
Is it mandatory that when OSPF neighboring is happening, the MTO size must be same?
Definitely, it has to be the same. That will
Uh,
make, see, it's not mandatory.
no,
Sometimes you will see that it is also going to be means establish the neighbors here. Like
yes,
in
yes,
some other vendor. Like, yeah, if I talk
yes,
about,
yes.
yeah, if I talk about some Alcatel or the Huawei or
Yeah,
the Juniper, it may
yeah.
allow that. So
In
it
fact,
basically the vendor is specific. Yeah.
Cisco does not allow. But, a command is
Yeah.
present that I think
Yes.
for that. There is a
So it
command
depends on the
to.
version. By default, it may allow or it may not allow. It depends on totally the version. But one thing is very clear about the MTU. Let me tell you that. See, if you have the two router connected to each other, and if your MTU size is not same, that's going to create a lot of problem. The packet drop, the delay, the processing, extra processing things. Why? Because if MTU is not same, what is going to be happen? If they are not going to be, means suppose if they are not going to agree on a mutual same MTU size, that's all the time fragmentation is going to be happen. That's something which is undesirable, right? It's totally undesirable. So
I
that need
think
to be fixed.
I think that is the reason nowadays in network everybody is open the jumbo packet.
Definitely,
But
that is the reason. Means, see, the reason is why fragmented packet is not allowed. You know that because all the hacker in all over the world, they are using this fragmented packet to hack a network. Why? What they do? A normal 1500 packet. In see, in many time in my network, I have observed that normal 1500 byte packet they divide it into something like a 70 byte. And think about how the firewall or the IPS or IDS can match anything from the 70 byte only, and they can easily pass out from the firewall or from the IPS and IDS. That is why any network will nowadays never allow the fragmented packet, because the hackers are using this trick to pass the security gate from the firewall, from the IPS and IDS. So it's better to recommend to use a same. And see, earlier there was a problem. Nowadays, what we are using in any scenario, you will see that we are using only the Ethernet as a media, right? So that is also not the problem. Okay, I have some network issue. Can you guys hear me?
Hear you, but skin is
Yeah, the
visible.
screen. Yeah, screen is blank. Yeah, because that I
Hmm.
disconnected from that. No problem. We'll see that. So that is the reason, because nowadays we are not concerned about that serial link of a 2 MB or the 1.4 Mbps. It is something like a 20-year back concept. Now we have the case of 10G, 100G. So that's a totally irrelevant, right?
Yes, right. Today, last we work with the 100 GB.
Correct. Nowadays, yeah, it's see, when I started at that time, 20-year back, there was a 10G concept. Means it was in a starting phase. Now, from the some years, we are seeing that 100 GB and it's working perfectly well. And the reason why these giga means Ethernet is popular because of the cheap. It's very cheap and it's very easy to work. It's not the complication like of the TCP or the serial links. So that's the things which is there. Let me check that again. I think some problem is there. Okay, I have a
Sir,
one
I
more
have
question, so I will check it. Yeah, I just Let me check it on the chat box. Is it fair
Sir,
to
I
say
have
that
one,
router cannot? Yeah. I have one question from the Ralph. Let me take that first. Is it fair to say that router cannot exchange LSAs into different areas without backbone? But do not worry about that. Do not worry about that. I will explain that how the LSAs are exchanged. This will be the next topic now. After a break, we'll take that also because there are 90% students, those who are confused with this simple things. What is the summary LSA? So we'll take that also. Do not worry about it. Okay. We'll take that part also. Let me
Mostly
open.
LSA4.
Yeah.
Mostly it
No, that
LSA4.
is called as a LSA3. That is called as a
Yeah.
LSA3, not LSA4.
Hmm.
We'll see that. It's even in the book. See, when I was like the same way you are very curious about to know that, I was also when I was doing my CCNA and the CCNP. But the problem was at that time there was no concept of virtual class. You have to go and attend a one-to-one class or a big class. There was no virtual lab. So you are blessed with the virtual class as well as the virtual lab. But at that time, it was very difficult to do that trainings of these things. All right, so I will come to that point. Do not worry about it. Okay. So yeah,
sir,
there was
sir, can
one
I ask one
question, yeah,
question?
about the LSA. Yeah, yes. Many questions.
Sir,
Whatever you have the doubt, ask anything.
yeah, can you please tell me how to troubleshoot in I mean init state to extract to exchange state? What type of
Yeah,
troubleshoot we are doing?
yeah,
Because
yeah.
many questions are asking in interview. In that
Mhm.
main question is MTU.
Well, see,
MTU, then
yeah.
extra.
So, yes. So the troubleshooting we are going to touch after complete. See, I always recommend to my student, even in the working professional, what the case is there. Sometimes a student come with a specific requirement that I want to learn troubleshooting, how to do that. So that's a totally interesting or surprising part is even the some coaching agree with that. Okay, I will teach you this troubleshooting. That's totally ridiculous. See, applying of your concept, the basic concept and the fundamental concept to the lab, that is basically to troubleshoot the network. There is no something is sophisticated or any extra thing is required. What I will do once any topic is completed, I will set the task, something like 1 to 5, 1 to 2, 1 to 3, like that. And each task there will be a something, some interesting fact, some concept behind it. So once each and every topic will be clear in the lab, you will never ask these things. That clear something, how to troubleshoot this, how to troubleshoot that. Obviously, automatically you will clear that. You will get the reason how to solve it also. Okay, so do not worry about the troubleshooting. Let it be clear each and every topic first. Concept, the logic should be clear. Once it is clear, the problem is in the classes. If you go and see in most of the online classes, they are concerned about the command like this way, and then showing you the output, and then this way. This is not something is going to work. So let me clear each and every topic this way only. Once I will clear that, 100% will see the troubleshooting concept also some, and I will give you the task also that how to solve this kind of a problem. So do not worry about it. Okay?
Okay, sir. Okay. Because
Yeah.
Inorio is asking how
Don't
to
worry. Once you will, yeah,
play.
once you will work with Miss, once you will complete your OSPF, that will be my promise that your boss or those who are experienced person, those who are there in your company, they will not be able to reply your questions. That is my promise. But if you revise it
Feeling happy,
properly
sir.
and you will complete in a proper way, okay?
Feeling happy, but I don't know.
No, definitely. But the only thing is you need to revise the class. Revise the class, note down whatever the thing you never know, you haven't listened till now, note down that in the notebook. That way you will get 100% output. If you are just listening here and then enjoying that, wow, what a thing, I get it. Obviously, you will forget it after 10 days. Again, you will go back to the zero. So the
Sir,
best
one
way
more
for
question.
any class, not for this class, for any class, the best way is to get a maximum output to revise it and make a note out of that. Yep.
Sir, one more last question. Last question.
Yep.
Sir, someone is asking for interview. The device
Mm-hmm.
is shut down, but
Mm-hmm.
logical interface is up. Okay. How should you troubleshoot?
Okay. Means
But I said the physically the device is shut down. But
devices are
I said what
shut down.
device is shut down. But logical IP is up only, right?
So that means
I mean loop address.
Which address?
So device is down, but a loop address is up only, right? Because that is a logical address, right?
No.
Let me tell you, dear. Once a device, see, logical interface will be only down when your device itself is down. Only in that case.
But logical address is not down, right? Because we are creating loop, right? I mean a loop.
We'll discuss it. Do not worry. I will clear that all your doubt, whatever you have. Do not worry about that. Okay? No,
Okay.
no problem.
Sorry for
I
disturbing.
will clear that all. Don't worry. I will clear that. But yeah, but the thing will be if you go step by step, that will help you a lot. So I will definitely go that way so that you can get the maximum output of that. Okay? Do not worry about it. All right. So we were here. Okay. So what we have done so far, we are going to apply that in the lab, the two things, and we'll see all the things, each and everything from the starting to the end. Right? So let's see that. IP is configured. Let me tell you what IP I have configured here. So the IP concept will be always that. That's simply that thing. Means all over the through lab will use a same IP notation because it's also confused when you are going to complete the lab. So let me tell you how I'm going to use my IP address. Between 8 and 10, the starting two part will be fixed for all the networks. 155.1. The third part will be according to my router number. It is 8 and 10. So it will be 108.0/34. Between 5 and 8, it will be 155.1.5 and 8, so 58.0/24. This way. And the loopback IP will be always in the range of 150.1. And the next two part will be of your router number, like 10.10. And I will recommend to you guys, if you use this way, what will be the case? You don't have to look it back again and again. One time configure, and for the whole lab, you do it this way. So that I will suggest to all the students that whenever you are going to practice, make a some rule that I will use the IP this way. Okay, so then you don't have to look back again and again. Otherwise, most of the time you will waste your time to only check your IP. Hey, what is the IP on my 8? What is the IP on my 10 side? Use this concept. The last part of the IP of the network will be your router number. If it is I'm configuring on the 10, it will be 10 here. If it is router 8, it will be 108.8. Like the same way here between 5 and 8, 58.8 and 58.5 here. And the loopback will be the last two IP. Let's check the access. Might be there will be some configuration, so no worry. I will delete that and then we'll show you them. Whatever we have discussed so far, we'll see that. And then after that, we'll take a break and then we'll see. There's some more interesting thing about the multi-area concept. We'll test that. So let's get back to this topology and the router thing. Right? So I will change the name. This name is R10. IP is already configured. If I go and show you that what IP I have configured, the same notation I'm using. See that 155.1.108 here, 150.1.10.10. Let me check that if there any protocol working. So OSPF is there and only OSPF is there. So I'm going to delete that. Okay. Same way I'm going to do the router 8 and show you the IP first. These are my two networks, 108 and 58, and this is my loopback. Let me delete quickly my OSPF also. No router OSPF 10. I hope this is, I believe, this is the only one. Correct. Same way, I will go on my router 5 and delete that and show you the IP address. There are many interface. Right now, I'm concerned only about 5 and 8, which is 58. This one. This link is up, and this is my loopback. Let's delete it from here also. No router OSPF 10. There should be no any other routing protocol. So yep, there is no routing protocol. Let's go back to the between 8 and 10 first. We'll configure the OSPF. So go to the 10 first and see that. Router OSPF 10. And what I'm going to show you, I'm going to type this command. Network 0.0.0.0 255 255 255. This is my wildcard. In wildcard 255 means I don't care. 0 means I care about that. 255 means I don't care. Let me type the area 0. So what do you think? Is this command is going to advertise the network 000 to my router 8? No. It's gonna to enable my OSPF on all the interface of my router 10. Suppose there are 10 interface, 20 interface, they all will be enabled by this one command. But that is something I will never recommend to you guys to do it in the production network. Because in production network, some interface are going toward the BGP, some are going toward the EIGRP, some are going toward the some static route. So that is never recommended in the production network. For from the lab point of view, you can clear your doubt whether this network command is going to advertise this network to my router 8 or it is something else to enable the OSPF on particular interface. It's done here. I will minimize it. Go to the router 8 now. There are two interfaces, so I will enable it on my two routers. Router, I believe router 10 something suppose.
Router.
OSPF 10. And do it on the two networks like this 1.108.0 255 and area will be 0. Second network is my 150. So let's do that also. 150.1.0.0 255 255 and area will be done. Right, 8 and 10 now become the neighbor. So we'll be able to see that the neighborship status of that. So let me quickly go and show you that by this command show IP OSPF neighbor. My neighbor, you can see it here with the router 10, which is the router ID of your router 10. This is the router ID, not the IP address. IP address of your neighbor is here. IP address here. Now you can ask, now how the router 8 get the IP address of 10? Obviously, whenever R10 will send a packet, there will be a source IP. From the source IP, R10 will know about that. So that is the thing. Then we have a concept of priority and the DR that we cover it in the in a different segment that is called as a network type. So don't confuse with that. Right now, just see the state as a full. Full means they have exchanged LSA with each other. All thing is done. Then we have a dead timer also. What is that dead timer? Dead timer means basically by default, routers are exchanging the hello packet on a broadcast network every 10 seconds. So if suppose router 8 is not getting any hello packet from 10, so what has to be done by the 8? 8 is going to wait for maximum 40 seconds. That is called as a dead timer interval. If in 40 seconds, 8 is not getting any OSPF packet from router 10, 8 will believe that my neighbor is dead, my neighbor is down. So 8 is going to terminate the neighborship first. Second, flush all the LSA that he was getting from the router. Flush it from that. And inform to the next router also, which is router 5. That's going to be happening. Inform that. This is your dead timer. So this here that you are getting 35, it's going to be changed. The moment you will get a hello packet, it will be reset to the 40 seconds. And then again, countdown watch will start decreasing it. So let me show you that. Sometimes you will get 38, sometimes 36, sometimes 34, sometimes 32, like this. Once you will get the hello, you will reset to the 40, something like this. Okay, so do not confuse with that. This is the first thing. And the neighbor state is your full. Let's see about that, the root, whether I'm getting any root or not. So show IP root OSPF. I'm getting just a one root from my neighbor 10, which is the loopback, because this network is already there. And there is AD value of the OSPF is by default 110 that you can change. And the second value in the bracket is your max rate. And you are getting the information that if I want to reach on that 1.10, I need to send the packet to this end, 108.10. And on which interface? On this interface. One more information is there. With that time that I know about this route from how much time? In the last 3 minutes and 16 seconds. So if you get a complaint that your route is going down, your route is flapping, any network is flapping. So the first thing you will check this thing. Yep.
Excuse me. Here is the AD value is 110 and 11 is that link cost
Metric.
is 10. Yes, link
Let me
cost is
tell
10
you.
and as that is connected, that means 1, right?
Yep. That all will be covered in the cost section, how the OSPF is going to calculate the metric. So do not worry about that. But you said perfectly well. That is true. All right. One interesting thing before I move ahead and show you. Okay, let me show you first the OSPF database also, the LSA things. There are two type of LSA right now I'm getting. One is my router LSA, which is called as LSA1. Then I have LSA2, which is called as a net LSA. There are the two LSAs I'm getting. See that in the LSA1, in the database, router 8 is also keeping its own LSA. See that 1.8.8 and from the neighbor also. And it is getting from the DR. Let's check that what is there in the router. DRBDR will check it in the separate class. So do not confuse right now. Let's check that what is there, what I'm getting from my neighbor, which is 1.10.10. We'll see that here. If I just show you the detail, you can see that who is the advertising router for this LSA. Obviously, the router ID of 10. I'm getting it on the 10. Number of link is there, the 2. Then I'm getting a loopback network, 1.10.10, and the mask of that. Metric of that also, which is 1. Who is giving that? Router 10 is giving. And then how they are connected. So the 8 and 10 are connected to this. There is a designated router and then router interface IP address is this. On that network, they are connected to the 8 and 10. And what is the metric of that network? It is a 10. That information you are getting. Now let's check about the network. Net. And then type this. Okay. Here you are going to get the information. The devices 8 and 10 when they are connecting, on which network they are and what is the mask of it. So mask is 24 and the two routers are attached, 8 and 10. And these are the router ID of it. And they are on the network mask of 24. So this is sent by the designated router. Who is going to send it? Designated router, which is router 10. So this is the case. Main thing is there in the LSA1. LSA2 you will not get in the case of when your network type is not the multi-access network. If your network type is something like a point-to-point or point-to-multipoint, in that case there will be no LSA2 because LSA1 is going to hold your all the network information in that. Right? This is the way how to check your LSA packet.
Do we discuss
each
this
LSA,
network type later?
yeah, definitely. It will be a separate class or one class will be there for this network type. For the for the area type, there will be two classes. Then there will be one class for your the multi-area concept, different things, root summarization there. So all will be covered slowly. So the first class will be always slow because I need to clear the basics from it. Once your basic is good enough, it will be easy for me to go ahead for the filtering of root because root filtering is the most difficult, most tricky thing in the case of OSPF. It is not something like our ERP and RIP. So the root filtering will be covered in the one class, the access list use, prefix list use, and distribute list how we are going to use, what is the range command. All things will be go slowly. In the first class, we are just covering the basic thing. All right, this is the case. All right, now let's go here on my root again. So IP root SPF, which I'm getting it as a 32-bit root and this one. Let's go on the 10 and quickly configure a one more loopback. This time I'm going to configure a loopback on 10, something like this. 150.1.100.100, and this time I'm going to keep my mask like this 24, not 32, right? Because there is a command of 000, so this will be also advertised to my neighbor in the LSA packet. Let's check that on my router edge. Go here and check. Okay, what I did the mistake. I give the LSA as a loopback 0 only. So let me quickly change it because I don't want that to change my loopback 0 at all. So loopback 0 will be as it is, which was 150.1.10.10 and 4 times 255. Next thing, I will configure a new loopback, which will be the loopback 10. In that, I'm going to configure my IP as a 100 like this. And this time my mask is a 24. Done. I hope there will be two loopback. That's it. Let's go to the 8 again and then check. I'm getting that 2 loopbacks. But you can see here, 150 this and 150, 100. But what is the problem here? The wrong information. What is that wrong information? For my loopback 10, if I go and show you here, my mask is 24. But here, what I'm getting my mask is as a 32. Yeah, for my loopback 0, there is no problem. For my loopback 0, my mask is 32, so I'm getting that as a 32. There is no problem for it. But problem is for this. My mask, I'm keeping it as a 24. Then why it is displaying here on a 8 as a 32-bit mask? Even if I go and check it in my database table of a router. See that? For the 100.100, my mask is given as a 32, which is totally wrong. So whether OSPF is not working properly or I have some problem in my router. So no, OSPF is also working, means OSPF is working properly as well as I don't have any problem. The problem is the network type stuff. OSPF by default, OSPF routing protocols by default take your loopback as a stub network. Stub network means something which will by default make it as a mask as a 32. Doesn't matter what mask you are going to write. Like here, I give the mask of 24, but still it is displayed as a 32. Why? Because of this reason. Loopback is a very special type of a network according to the OSPF that is called as a stub network. So because of that, it's going to take it the mask by default 32. So never confuse with that. In any case, if you suppose you have the loop back and your mask is not 32 and you are checking in your neighbor that, hey, why this is a wrong information there about this 1.100.100, then my mask is a 24, then why it is displayed as a 32? So that is the reason, because by default OSPF take it as a stub network, and for a stub network it's going to keep the mask 32 by default, right? So similar like that, many more thing is there in the coming classes about the summary and all that. Whatever the confusion, whatever the wrong information is there in the market, that will be clear in your mind once you will complete your things. So let's take a break. Okay, 15 minutes, something like a 15 to 20 minutes. And after the break, we'll continue and I will give you the brief intro about a multi-area concept of the OSPF. Just a brief, I say. So then you will understand that why the multi-area concept is helpful in the large environment. Because right now you know about the theory that, yeah, in the case of large, I need to use the multi-area. But why to use? What is the benefit? I will show you in the lab itself. So let's take a 15-minute break, something like that. And we're gonna go ahead with the multi-area concept after that. Right now,
Sir,
if you
can
have any
up
doubt,
to
you can
what
ask.
time we have class?
Sorry?
The class timing is up to what?
Class timing is the same that we have started today, or you are asking after the break?
Yeah, up to.
Yeah, after the break means something like a 15 to 20 minutes will be break, and then we are going to have means on the same link. I will not disconnect it. This same screen will be displayed here. In that 15 to 20 minutes, we'll continue with our multi-area concept. Okay, multi-area
Okay.
concept. All right. Till then, if you guys want to have your dinner or you want to have a cup of tea, coffee, you can have. We'll continue with that. Okay. All right. I will be only on the mute for that 15 minutes. I also have to take my, yeah, we cannot give break. There will go. Okay, the backend team is telling that rapid it means we are going to wrap it after completing the multi-area without giving the break, right? So let's complete that also, right? Will not take more than 20 minutes. So we are going to complete that multi-area concept also here. So for the multi-area, are you guys able to hear me?
Yeah. Yes,
Okay,
yes.
so we are not going to, we just cancel the break. Let's continue in a flow so that you will get a better idea. In 20 minutes, I will be able to complete that. Then we show you that. The multi-area concept. One thing is clear that multi-area is used in the large network, in a large environment. Why it is used, that I'm going to clear it right now.
Abhishek,
So,
one thing.
yeah, yes.
So after this class, are we going to start the BGP session today or how it is, Abhishek?
BGP, we are not going to cover today. Tomorrow, will clear it with the backend team. We'll inform you. Don't worry.
All right. Just for the information, I asked you.
Suppose you guys want to go for the demo for the BGP also. So we'll arrange it maybe in a separate time or how the backend team is going to arrange. We'll see that. Okay.
Okay.
Yeah, for the BGP. We'll see that how we can arrange it.
Will we get the recording of this class?
Obviously the backend team will inform you about that. Will you get the recording or not? 100% you will get that. All right, so let me go with this and we'll see the OSPF multi-area concept. When it is not required, you guys can keep your on a mute so that should not disturb anyone.
Not taking break.
Yeah, we are not taking the break.
Okay.
We are going to continue with this multi-area concept. Then we are going to wrap up the class. I was thinking that go ahead for the maybe or a 1 hour more, but no, we are continuing to multi-area concept only, and then I will close the class. All right. So what is the case in the area? Basically, what is happening when I'm going to use a multi-area OSPF concept? It is used in the large network that I already told you guys. So what is the reason behind it? The reason behind it, suppose if I have 100 routers or more than that even, and I have thousands of network, if I'm going to keep my all the router in a same area, the problem will be a flooding of LSA. Because see, it's not a one-time activity that any router is generating the LSA and it's the neighbor to the next neighbor, neighbor to the next one. No, it's a repeated process, a periodic process. It's not a one-time activity. How? Something like a 30-minute to 45, something like in a real scenario, 30 minute to 1 hour, max to max 1 hour. The max age time of a LSA is a 1 hour. So in that time, whatever the LSA you have generated, you have to regenerate and resend it to the all route to your neighbors. So flooding will be always there. After 30 minutes, after 45 minutes, you will see that a lot of flooding is happening about the LSA. So that's created means totally a disturbance in the whole network. Total network, you will see that it is unstable. All the time, routers are busy to find out the best path to reach on this way and that way. Because it's very usual that in a production network, any network can goes down. Not in the virtual lab, but in the real environment, any link can goes down. Any one link is going down, and all the 200 routers are going to be busy to calculate the path, another way to reach on that. So that's something which is not possible to manage. That's why OSPF recommend to use a multi-area. Multi-area basically means divide a one big large network into many small networks. Like this way here I did that. I have so many routers. I just divided in a three part: area 1, area 0, and area 2. In the multi-area concept, one thing is very important. There will be always a area 0, and all non-zero area will be connected directly to area 0. This is the first thing. So it's not possible that you configure a two area like a area 1 and 2 and then try to communicate with that. It's not going to happen. Why it's not going to happen? The reason is this. The communication between the two area is possible by the ABR router, area border router.
Abhishek,
Area border router. Yes.
if you talk about non-zero areas,
Like area 1, 2, 3, 4, like this.
yeah, whatever it may be, by default, it should be connected to area 0, right?
Yeah. Any
We can say
non-zero area has to be directly connected to the area 0.
all that, okay.
If suppose you are connecting area 1 and area 2 directly, like suppose if I make a one more area here and connect them, nothing will be exchanged between that two areas. Why? The ABR is the reason. Because any LSA will be exchanged between the two area only by the ABR route, area border route. And which router will be called as the area border router? That is also interesting. The router which has at least one interface in area 0 like this, and a one area at least in every non-zero area like this. Only that router. So suppose if I'm connecting one router here, and I'm going to keep that in an area, suppose a 4, like this. So this router will never be called as a ABR because it is connecting area 1 and area 4. So this will never be called as a ABR. ABR you will call only the router which having at least one interface in area 0 and at least one interface in any non-zero area. That will be called ABR. And ABR is the only router which can exchange LSA between the area, not any other route, nowhere. Only the ABR. So what happened in the case of multi-area concept? Let me quickly delete all these things. I will just plug it here. This is my ABR. This is also my ABR. Yeah, this is the first class, so might be you will get the ASBR. We're not talking right now. Don't worry, we'll cover that also in a greater way, in a great length. Don't worry. When I will talk about the area type, ASBR will be also ABR I'm talking about. So what happens? Suppose this router is going to make a one LS, this router, because each router is going to generate their OS. It's going to write the original ID. ID and whatever the network information you have, whatever the mask information, the metric information, and then basically it is an IP packet, so there will be a checksum, right? There will be a checksum. That you know that in each header, like IP, the MAC or the TCP, there will be always a checksum. For what purpose we have the checksum in the packet header? For the integrity, whether any bit or byte is changed or deleted in the packet or not. So what happened? When this LSA will go from this router to this second router here, it will store it and forward as it is without changing the checksum, network, originator ID, nothing will be changed to the third router. Third router will also store this information in the database and forward as it is without changing the any field in that packet. Not a bit will be changed by this third router. Share it to the ABR. Now, once ABR will get it, ABR is going to change. What ABR is going to do it? ABR is going to write down, means it's getting it as a LSA1. ABR is going to generate a new LSA, which will be called as a LSA 3. Out of this LSA, this was my LSA 1. You get it from the last router here. Once you get that, ABR is going to generate a new LSA. That's called as a LSA 3. Here, ABR is going to write its own originator ID. And it is going to copy all the network mask and metric, all that here. And it's also going to write the metric here, apart from your network and mask information. And then a new checksum will be created. Why? Because you have changed the originator ID, you have changed the network, whatever you have done, you will do that because you are creating a new LSA. So the new checksum will be created. Now, only this LSA will go from the ABR. I'm not playing, I'm not summarizing anything. Whatever is their network in the LSA 1, the same LSA will be there in LSA 3 also. I'm not playing with my network, I'm not summarizing it. So never confuse that why we call that LSA 3 is called as a summary LSA. It is not because my ABR will summarize these network, whatever is available in that LSA. No way, nothing will be summarized. What is the reason behind it? We'll also see that. So this is my ABR. ABR is now going to forward whatever the information was there in LSA 1 as a LSA 3 to my areas. And now this will travel the same way. This router, everything will be the same. No checksum, nothing will be changed. On this router, everything will be the same. This router, everything will be the same. On ABR, again, it will be the same. Now, when he is going to send it to the another area, this time it's going to change. It's going to change that I am going to send it to this area. It's not playing with that LSA3. It's going to send it to this area by its own originator ID and its own matrix regulation till here. And new checksum will be added and send it to the area. And all the router will use the same things. Nothing will be changed by any router in that area. So you get the basic idea that basically what is happening in any particular area, LSA 1 and LSA 2 will be there. Depends on which kind of network. They will never cross the boundary of the area. Means my LSA 1 and 2 can never cross the area 1 and go to the area 0. No way. Whenever they will reach to the ABR, ABR is going to convert that LSA into the new LSA. That is called as a summary or LSA 3. Going to write its own information and going to send it to this area 0. When again it will reach to the another ABR, that will again change it and send it to the next area. So what is the beauty? Why we call it summary? If suppose this router was sharing these 5 routers, 151.1.1.0, 151.2.0, 151.3.0, 151.4. Suppose these 4 networks. So my ABR is not going to summarize that 4 networks something like a 150.1, 150.1.0.0. No, that's not going to be happening. So what it's going to be done? Everything will be as it is. Only changes will be that when these router will get, suppose this router is getting these LSA and is storing that network information here, 150.1.1.0 with the mask of 24. Now, what this router is going to do, it's going to calculate the SPF algorithm, SPF algorithm, shortest path first. It's going to calculate the SPF till here only, not till here. No way. Now the scenario is changed. In the case of multi-area, any router will calculate the path till the ABR border or the area border, only till here. Same way, all the other router, like this router, will calculate how to reach on that 1.0./34, will calculate till here. Because now in another area, these routers are depending on the ABR. Whatever the ABR is giving the information, suppose ABR is giving that, if you want to reach on that 1.1 network, the cost to reach on that is 50. You will believe that. Something like between the area, OSPF behavior is something like a distance. So now these router will take that 50 cost as their starting cost and they will add their own cost. How can I reach to the ABR? Suppose reaching to the ABR by this route, It's suppose 30. So they will install this router as a 50 plus 30, 80 cost. This router, suppose it is reaching with the cost of 10. It will store it as a 60 cost. So they are limiting their SPF calculation in the case of LSA3. They're not going to cross and find out how to calculate the SPF till the originator of this network. No way. So the behavior of OSPF between the area is somehow distance vector. This router will never know who is behind this area because AVR is giving you, because AVR is generating that LSA new. They are not going to get the LSA1 information from this router. They are getting this information from the LSA3. So they will never know this router, this router, this router will never know who is behind my AVR, how many routers are there and how they are connected. That is why we call it as a summary LSA. You are limiting your SPF path calculation till the AVR and totally blank who is behind my AVR. Something like a distance vector between the area. That is the concept of your multi-area OSPF. And what is the reason of doing this? The reason is now, when any time this network is going down, suppose 1.0 is going down and then coming up. When it is coming up, what is happening? These router will flood that LSA1 to each of them. And they all will be busy to calculate the path, how to reach on that network. But this area will not be busy to calculate the path till here. No. What they are doing? They are only limiting their calculation till this route, till the area. So their processing power will be less and more. And that is the reason. Anything is going up and down in a one area will very less is going to affect the another area. Yeah, LSA will be there, but the calculation of SPF path will be limited now. And that is the reason of using the OSPF multi-area concept in a large network. So instability about any network in one area is not going to hamper any other area at all in a larger perspective, I say. Right? That is the concept of your, and only the ABR will generate that LSA3. And LSA3 is called as a summary LSA. That is also important. If you check in the book, I don't know, but you see, when anyone is writing the book, somehow in the reference book, you will get the detailed information. But some other books, you may not get that. Why we call it as a LSA3? Not because it is summarizing my this 4 network and sending only 150.1.0.0 to my this router. No, it is summarizing your SPF calculation, shortest path first calculation till the ABR, and you are not bothering who is behind my ABR and how they are connected. It's not your concern. That is the concept of summary LSA. Right? So the way we have discussed right now, we'll see same in the lab also, but not today because we haven't taken the break. So we'll stop here. So something like a 2 hour continuously I'm talking. If you guys want to ask something else, you can ask, but this will be my style. No PowerPoint presentation, nothing will be used. I will explain the simple concept, then I will show you the same in the lab. Anyone
Sir,
who
I have
want to
one
unmute?
question.
Yeah, yes.
Sir, how the shortest path calculation, sir? Once again, you can tell me that shortest.
Yeah. Shortest path is basically the algorithm. Suppose this router, suppose this is my router 5. And there are something like a 4 to 5 way to reach on a particular network. Like this way, it's connecting a one more router here. Like this. And this router is connecting to this router, then this router, then this router. So there are many ways by this router can reach or to the AVR, right? There are 1, then there are 2, then there are 3, then there are 4, 5, 6, like that. Many paths are there. So what your SPF algorithm is going to do, SPF is going to build a SPF tree to all the possible way how to reach to the AVR. And all that possible way, it will compare that cost, that which having the lowest cost. Cost doesn't matter that the physical distance. No, SPF is going to only find out the one thing, the cost, the high bandwidth path. If the path is high bandwidth, your cost will be the low, and the low cost path will be followed by your router. That is the simple algorithm of your SPF. First of all, your router will make all the possible branches to reach on that particular one network. And out of that, it will compare the cost. The lowest cost path will be selected as the best path. If that down, you will
So
select the next
I
best
mean,
path.
one interface is 10 GB, one interface is 1 GB means it prefer from 1 GB or else a 10 GB interface.
Definitely the 10G. Why? Because the cost of your bandwidth depend on this thing. The reference bandwidth divided by your real bandwidth of the interface. So the more the bandwidth you have on your interface, like a 10G, the cost will be the lower, right? The cost will be lower. The lower cost will be always preferred. So 10G will be preferred. But one thing you need to take care, because by default in OSPF, the reference cost is only 100 Mbps. So the problem with the 100 Mbps by default, it is not going to make a difference between 10G link or the 1G link. It will treat both as the same. Treat both as the same.
Okay.
So it is very important, check that whether the reference bandwidth is changed or not. And in today's scenario, it must be changed. You should never use the reference bandwidth 100 Mbps at all. If you are using the default one, it means you are creating a trouble for your OSPF. It has to be very high so that it can differentiate between the 1G, 10G, and nowadays 100G. Otherwise, for all, but you see, if I'm using the default one, so for all the three cases, my cost will be one. For all the three cases. And you will see that your OSPF is doing a load balancing. And you're totally confused that, hey, the 100G is the best cost. Then why not using this one? Why it is doing the load balance? Because of the reference band. Reference bandwidth by default, because see, at the time it was designed, no one was aware that in future we are going to have a 10G links or the 1G link. So that's why
Sir,
the
one
reference
more.
bandwidth is very low. Yep.
Okay, one more last question. Sir, for one router, one interface is OSPF configuration, one router is static router configuration. Okay.
Static
So,
router.
static router. Okay.
Okay.
Which is preferred? I mean, OSPF or else static? Because static is
Always static, because static having the AD value by default as a 1. So that will be always preferred.
okay. You can assume one is BGP, one is static. So tell me, sir, now.
Sorry, only static and
So, sir, one is static, one is BGP. Which one is
yeah,
preferred?
in that case also, because see, any routing protocol, they have more AD value than your static route. They're all having, like a BGP having the 20, OSPF having the 110, EIGRP having the 90, and
Sure.
RIP having the 120. Like that.
Okay,
This
it
is the
was the
case.
same question asked there.
Yeah.
Why
Now,
TCP
let
is
me
not?
tell you. Yeah. Now, let me tell you. This is the default behavior. If you are changing your static admin value, something like a 130, obviously that your static will not be preferred. So don't call it as a routing protocol. Call it as an AD value. Check the AD value, and then you will find out that which one is preferred. Why? Lowest will be always preferred. By default, this is the case. So static will be always preferred. Yes. What was your next question?
Thank you, sir. Thank you, sir. So, same number. If we change it with the 80 value means the traffic will go from BGP, correct?
Correct.
Okay, thank you.
Right.
That's it.
All
That's
right.
it.
So all good. Thank you for listening me from the last two hours, for your patience, for all that, making the class very interactive. Yes.
ABR all time summarize the whole network and then coding the other network as a LSA tree, right?
No, what I said, ABR is not summarizing the network. It is sending as it is to the next all the router in the area 0.
Okay.
What it's doing is forcing all the rest router to limit your SPF calculation till me. I will not tell you who is behind me. That is the case.
Okay. Wonderful. That means
Not summarizing, yeah.
as it is
That's
as it is advertising, but for reachability, he said is own IP, right?
yes. All right, guys. You can ask even tomorrow class also. Will be allowed to ask as much as you want to ask in the tomorrow class also. Please unmute if you are not asking. And see, there is a link given in the chat box if you want to inquire about the admission All is given there, the phone number, the website information. The backend team is going to contact you as soon as you want. So check the chat and connect on the team. They will ready to reply for your any question regarding the admission process. Okay.
Okay, sir. Thank you.
Thank you.
Okay. Thank you, everyone. And this is the chat box. Check that, and the phone number and website information is there. Check there. The backend team is waiting for your reply. Right? Children, bye.
Tomorrow again class plus BGP or OSPF?
The BGP. Tomorrow we'll see the BGP because there are a lot more confusion also in the BGP. We'll clear that basic things. Okay.
Okay.
All right.
Good night.
Bye, guys. Yeah.